Hello. Fix my screen real quick. Yeah. Wait 2 seconds. Let me find it. OBS. Okay, now tell me, what lecture number is this? 14 or 16? I don't remember. What's the number? Anyone? 14. If it's wrong, then blame him. Okay. Wait. It should be even though because today is Thursday. 15? Wait. No. Wait, is today Tuesday or Thursday? Today is Tuesday. Sorry about that. 15. Okay. Odd number. Are you okay? No, I'm tired, but I'm okay though. You got a new haircut? No, I just shower. I went out for food, so I come back, so I need to shower. Okay. And why are there only 16 people? They gave up on life because they're doing midterm or what? They dropped the class or what happened? Why there are only 16? How hygienic. You should. Right now, if you go outside, you should come back, take a shower, and wash your hair. That's actually recommended. I think it's recommended by the what's that called? CDC and a whole bunch of other things. I'm not sure. I think I read it somewhere. It's recommended to do. But you know, when you go out and eat something, right? Sometimes it smells like I went and eat shabu, so the hair is all gone. Okay, so what we're gonna do today is the following, right? Because I want to eat buffet for many months, except they're all closed. Okay, so today we're gonna talk about food. Let's talk about sushi. Sushi. Let's talk about sushi. Okay, so here's a problem. Here's a problem. I have, I don't know, I have 15 sushi. Okay, 15. Actually, let's make it 10 because I'm too lazy to draw 10, 15 sushi. We have 15 sushi, and I have, I don't know, I have 5 students. Oh, that one I know. It means the thing, the food you like. I know only basic kanji. Sushi. There are 10 sushi, and let's say they're all identical, by the way. Okay, and there are 5 students. So there are many ways you can give 10 sushi to 5 students, right? You can be fair and make it 2, 2, 2, 2, 2. Or you can like the first guy a little bit more, and you hate the last guy, so you can do this, right? Or you can, I don't know, you like the first 2 guys, and you really hate the last guy, right? But okay, so far so good, right? There are many ways to give 10 sushi to 5 students. But let's see, for now, let's say that this thing is too cruel, such that someone doesn't get a sushi. Okay, that thing is too cruel. Right, it's too cruel. So I want to count how many ways are there. 2, give sushi to the student. So make sure that everyone, by everyone gets at least one. This actually make the problem a lot easier though. Yes, every student has a name. So this thing is Keith. This could be Saran. Who else? This could be Nawat. And that could be Justin. And who else? Tell me the name. And this could be Titiya. But they're all different. How many ways are there? I'll give you, okay. So for this thing, you need to think a little bit harder. It's not obvious how you would count them systematically. Okay. This thing make it so hard. Make sure that the total is 10. Okay. So I'll give you, I don't know, 5 minutes to think about it. Give me a good answer. Give me a good answer. Remember this thing, and everyone get at least one sushi. Okay, think about it. I give you 5 minutes to think about it because you need to think hard on how you would do this systematically. And let me tell you, this is the hard part. Okay, this is actually makes it easier, but we're gonna drop it later. If we do this, what happened? Oh, who the hell? Where? Okay, that's new to me. Anyone? Anyone has a good idea though? You can share your idea. How would you count them systematically? Make sure that everyone gets 10. I want to get some wrong idea as well to make sure that you know what went wrong with the idea. Yes, you can supply wrong idea. That's good too. Okay, right. So Keith suggest something interesting. So there's Josh says 5 factorial. Saran say 4 factorial plus 3 factorial plus 2 factorial plus 1 factorial. All sushi minus 5 then Oh, what? We start with the lowest number. It's okay, but I want you to think along though, to know that there are certain difficulty in doing this, right? Okay. Wait a second. Go back. Okay, so let's think about this systematically. So, Josh, can you tell me what 5 factorial is? What 5 factorial is? No, no, not the number. Why is your answer 5 factorial? Sorry about that. I wasn't clear. Why is your answer 5 factorial? Well, what did you count systematically? Hong Chai said 20. Maybe, I don't know the number. But why? So Saran, prepare. Why is your answer look like this as well? What is 4 factorial? What's 3 factorial and so on? 5 to the first. Okay, good. So let's think about this. Josh claimed the following. 5 factorial come from the fact that, okay, the first guy has 5 choice, right? On how many, on how many sushi he can get, right? He could get 1, 2, 3, 4, and 5 sushi, right? And then the second guy, actually, if you think about it, there are 5 choices as well, right? Right. So Josh answer, it should be more like 5 to the 5, right? 5 to the 5, right? This is number of choices or something like that. The first guy can actually get like up to what, how many, 6 sushi or so. But you can kind of see clearly the problem, right? If the first guy choose 5, the second guy cannot choose 6 because you have too many sushis already. So there are certain restriction that makes it so hard to count. Okay, so let's think about this. This kind of problem is called stick and stone. Let me tell you, the technique is called stick and stone. But I think everyone appreciate the fact that there are a lot of some constraint that you really can't get it right. Okay, you see why it's called stick and stone. Or you can, okay, let's call it sushi and chopstick. That works too. Sushi. Actually, let me do this. Stick and stone. But in our case, it's sushi and chopsticks. You see why I call it like that. Okay, so let me make it salmon is pink, right? Well, this no salmon is not pink. Pink salmon is probably go bad already. Okay, salmon is orange. So there's salmon number 1, 2, pink is tuna is red though. 3, 4. Wait, to get. Let me put all the sushi line up. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are all the salmon sushi. Okay, here are all the sushi, and you want to make it into 5 groups, right? To give it to 5 students. What would you do? What would you do if you have a chopstick? What would you do? You want to separate them into 5 groups to give it to the students. What would you do? No, you don't even give them chopsticks. Pick the sushi, right? So essentially, what you want to do is to partition this. The sushi. I'm not sure if the sushi in plural is with an S or not. I'm not sure, but you get the idea. You want to partition this. So how would you partition the sushi to tell like which one is belong to which student? 5 group. What would you do with the chopstick? Here's what I would do though. Let's make the chopstick. I don't know, white, black. Let's make it black. Good, right? If you want to partition it, okay, how about this? How about this? I'm gonna do this, right? I'm gonna put a chopstick there. Okay, and however many on the left of the first chopstick, that's what the first student is getting, right? This is the first student. So how many chopsticks do I need to separate into 5 partition? You need only 4, right? So can you tell me how many ways are there? Can you tell me how many ways are there? Perfect. What is it equal? Oh, Keith, you may be right, but you're wrong. Think about this. So the question, right? The question of partition the sushi is exactly the same question of placing the chopsticks. Right, Hannah said 9, choose 4. Why is it Hannah? Can you tell me what is 9, what is 4? Very good. So there are 1, 2. Actually, let me change the color 2 seconds. And the color should be red. Okay. 2, 3, 4, 5, 6, 7, 8, 9. There are 9 places you can place the chopsticks, right? Okay. There are 9 places you can place the chopstick, and you pick 4 to place the chopstick. And whichever guy get the first position, this is whatever Mr. Student A, this is whatever student B, student C, and student D, and student E. Is that one good? Okay. So this is actually, so the number of partition of sushi is exactly the same number of how many ways are there to place a chopstick. So there's a one-to-one mapping on how you place a chopstick and how you would give sushi to the students. Are we good? Are we good? Is everyone good with this answer though? 4, this is the number of chopsticks. This is the number of spots for chopsticks. Okay. Good. So think about this. Each way you place a chopstick, right? So if you fix a chopstick, fix the chopstick placement. That means you know exactly on how many sushi you are going to give to each one, right? So for example, this kind of chopstick placement is 3. Oops, sorry about that. Let me fix the color. It's 3, 2, 2, 2, 1. Right? If you pick another kind of chopsticks, right, you're gonna change the number 1 and number 2. Are we good? Keith, are we clear? Right? If you place the chopsticks already, the number of sushi each person gets is already fixed. This is the key idea. Okay? The number of ways you can place chopstick is exactly the same number of ways you can give the sushi to the student. Okay? But let's check this answer whether it does exactly what we need. Okay? So there are 2 constraints that we need to meet, right? The first constraint is to make sure they add up to 10. How did we guarantee it? How did we guarantee? Or you can look at like that. That works too. How did we make sure that they add up to 10? What would be your answer? How does this method make sure that you add up to 10 always? Right? Because I'm not sure if I'm clear on the question. Okay, but I want you to think about it. How do we know that we're gonna add up 10? And the answer is simple, right? When you place a chopstick, you did not destroy or create a new sushi, right? So that means no matter how you place the chopstick, the number of total sushi is going to be 10 anyway, because when you place a chopstick, you didn't change anything with the number of sushi, right? So I think that part is clear. Okay. So the second one is, are we sure that everyone get at least one? Why is zero never happen? Why is it that zero never happens? So for example, the only way you're gonna get zero, right? The only way you're gonna get zero is if you have something that looks like this. Let me fix this a little bit, right? The only way you're gonna get zero is you have something like this, two chopsticks in one space, right? Right. The only way you get it, but the way we pick, we calculate 9 choose 4. We choose non-identicals, right? We have 9 spot 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9 spot. We pick 4. We choose 4, so they are non-identical. So that's we guarantee. Are we good? So this works. This method of chopstick works because you have this condition, which make it so much easier. Is everyone clear though? Is everyone clear? Everyone clear on 9 choose 4? I want you to be clear on 9 choose 4 and these two because it's not quite obvious. Are we good? We're gonna get there. We're gonna get there. We're gonna get there about the condition that doesn't exist. Okay. So now how about this? How about this? How about I still have 10 sushi and 5 students? Okay. Any questions so far on this one though, before I change the question a little bit, make it a little bit more confusing? Any question on this one though? But this is the basic idea for like half of today. This is the basic idea. Any question? Yes, no, maybe? Okay, so let's do the next one. Yes, without the condition, what wouldn't, okay, we're gonna get there. So let me change the problem a little bit before we get to the question of without the condition. Okay, let me change the problem a little bit. We still have 10 sushi. And there are 5 students, the same idea. Okay, 5 students, but I may or may not give all the sushi. Okay. So that means the number of total could be 9, could be 10, could be 8, could be 5. Well, I'm full right now, so no, I'm not keeping it for myself. Maybe I don't think you deserve it, so I don't give you the sushi. But you could use that idea. Okay, so I may or may not give all the sushi, right? But still, let me put in the condition. But still, everyone get at least one. So the question is, how many ways are there? I know what you're thinking, but I can tell you, so close, but not correct. So Saran said, okay, let me put Saran in red. Okay. Okay, I'll give you 3 minutes to think about it. Think about it and tell me. Saran, give me 9 choose 5. Know what? You may be correct though. You may be correct. They all add up, right? Okay, if you answer this one, then I can teach you something else as well. While we're on the topics. In the meantime, Nawat, can you fire up Python real quick and calculate this number for me? What is it? There is a map.choose. Can you fire up Python, calculate this number for me while we are waiting? Right, if I remember correct, there's a function called map.choose. Yes. No, maybe, or maybe not. If not, then write your own. That works too. Oh, map.com. I'm not sure which version has it. New in 3.8. Okay, these two answers actually deserve some merits. Both of the answer. Both of the answer deserve some merits. Okay, so any other answer? Any other answer? Are you sure? That looks like a prime number to me. Is it a prime number? It shouldn't be a prime number though. Right. That doesn't sound right. I think it's a lot more. Yes, Wolfram Alpha for me, this number. Any other answer? You guys? Any other answer? Okay, so let's do this. So Saran, can you tell me what's the idea behind this? What's the idea behind 9 choose 5? Let me make my salmon color. Yeah. In HTML, there's actually a color called salmon. You can actually choose that. Okay, so Saran said the following. Saran said something very interesting. Saran said, okay, we know, right? If there were no student 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 sushi, right? We know how to give it to like 5 students. So the number 5, and that's how we get 9 choose 4, right? So an idea would be, okay, Ajahn, that's easy. I'm gonna make another fake student. So they are fake student. Okay, right? So that means now we have sort of 5 students plus, let's say plus the Ajahn. Someone said that Ajahn keep it to himself, right? So that we can think about this. There's a 5 student plus Ajahn. Okay, 251 is 251. Okay, 10 sushi, 5 students plus Ajahn. But think about this. Think about it. Is this correct though? Is this correct? What did you miss? So that means you're placing 1, 2, 3, 4. 5. What can go wrong though? What can go wrong with 9 choose 5? You're so close though. Can anyone help Saran fix it? His answer was so close. What is wrong with doing this? Remember, the last guy is Ajahn, right? The last guy is Ajahn who took away the sushi. It might not add up to 10. Yes, but that's kind of key, right? But you sort of right. You sort of right. Is there anything guaranteed for Ajahn though? Is there anything guaranteed for Ajahn if you do this? Ajahn is guaranteed to get at least 1, right? Is that one good? Right? But not exactly what we are looking for, right? What we are looking for that I may or may not give all the sushi. Right. What about if Ajahn doesn't keep it? So can you fix this problem? Can you fix this? There are 2 ways to fix it, a cool way and a not so cool way. There's a cool way to fix it and not so cool way to fix it. Can you tell me how to fix it? 9 choose 1, no. Okay, plus 9 choose 4 is actually better. Okay, you can do this. Plus 9 choose 4, right? Because this is the case where I give all the student. This is the case where I keep some to myself. Are we good? But let me also show you. There's a much better way, a cooler way, right? Remember that the way we pick the slot is we pick it in between, right? We pick it in between the sushi. But if you think about it, Ajahn, where else can Ajahn chopstick be though? Where else can Ajahn chopsticks be? To the right, right? There is this spot that Ajahn could be. Are we good? Right? That new spot. So if Ajahn pick this spot, then it's guaranteed that Ajahn doesn't get anything. Are we good? If Ajahn is here, right? If you choose here, that means Ajahn doesn't get anything. Is everyone good on this idea? So that means the other and okay, let's call it the cooler Saran answer. So how many of them are there? So how many of them are there? Exactly 10, choose 5. Okay, so far so good. So far so good. And I claim that these 2 guys, you can calculate the number. They are exactly the same number. The last one need a little bit of fix. Okay. These 2 are the same number. You can punch it into Wolfram Alpha. What is this number though for those of you who are with Wolfram Alpha? 10 choose 5 is what? 252. Now you know. Now you know this guy is missing 1. Then we're gonna figure out which one. And this guy is also 252, right? Okay. So think about this. There are 2 answers that may or may not look the same. And this is why I tell you to please put in the explanation in the homework. It's homework 6 right after the midterm though. You're gonna need to do homework 6. So put on some explanation. Okay, this term, Ajahn give not all the sushi. This one for give all the sushi, right? 9 choose 4 is from the previous one. It's from this guy, right? Because we know that 9 choose 5. 9 choose 5 because you forgot the last one. Ajahn is guaranteed to get at least 1, right? So that means all you need to do is add up the case where you give up all the sushi. So you add another 9 choose 4 to it. Are we good, Thanatat? Did I answer your question? Okay. And you can see these two are the same number. But if you think about it, underlying idea is basically you are counting exactly the same thing, right? You're counting exactly the same thing. You're counting the number of ways, right? You're counting the number of ways to give the sushi to the student. Which means if you count it correctly, even though they do not look the same, they have to be equal. So this kind of thing is called combinatoric proof. Okay. This kind of thing is called combinatoric proof. You can actually make this more general, right? That number 10, you know that I make that number 10 come from, right? That number 10 come from the fact that I have 10 student, right? N student, and let's say K N sushi, K student, right? Is equal to, you can see N minus 1 K, 2 seconds, N minus 1 K plus N minus K minus 1. Yes, it's called combinatoric proof, or maybe combinatorial. I don't know. I'm bad at English. Justin, native speaker, tell me which one. Combinatoric or combinatorial proof? I think combinatoric proof sounds more familiar to me. I'm bad at grammar, but I ask a lot of native speaker though, like which one, and then they tell me, dude, you're Asian, you should know better grammar than me, and I don't. Okay, so but everyone sees, right? The idea is the following, that if you count exactly the same thing twice, right, you should get exactly the same number. You can make up the story that makes it more generic, right? Like this guy. Really? Combinatorial proof? Okay, okay, okay. I'll change it. Sorry about that. Okay. I don't know. Combinatorial proof sounds cooler. But everyone gets the idea, right? That you can prove things this way. So for example, if I ask you to prove this, you can make up the story that you want to give N sushi to K student, and then you show that there are two ways to count them, and they better be the same because you're counting the same thing. Okay, a lot of proof that involve like N choose K or a whole bunch of factorials typically has a combinatoric proof equivalent. So the one on your midterm as well, I'm pretty sure there's a combinatoric proof equivalent, but not do it with combinatoric. It's gonna take a while for you to come up with a story. Okay, just do, the usual method. Okay, so let's go back to this answer. Now what answer? Okay, let's go back to this answer. We're gonna come back to combinatoric proof in a second. Now what said the following, right? I think it's clear to everyone that the answer looks like this because 9 choose 4. This is give 10 to 5 students, right? So for this one is give 9. This thing is give 8, give 7, give 6. And exactly, you forgot 4, choose 4. And this thing is give 5 sushi. Are we good? Right? So everyone clear that now what answer is also correct, which means you have another combinatoric proof, right? You have another combinatoric proof for another identity, which means that this guy and that guy and that guy, they better be the same. Okay, so we have done also a combinatoric proof, a combinatorial proof of we claim, right? N choose K. Remember, N is sushi, K is the student, is equal to N minus 1, oops, K plus NK, right? And it has to also be equal to sum from I equals what? 4 to 9, which is I equal to 4. 4 is what? Oh, sorry, n minus 1, k minus 1. Okay, that's why it looks weird. From k minus 1 to n minus 1 of I choose k, which doesn't look, at least I think this guy doesn't look obvious to me. That's gonna work out, right? At least this guy, they do not look obvious to me. That's gonna work out. I just copy Noah's answer and make it a little bit more generic. Okay, so I just generalize number 9 and number 4 over here. Okay, this is 9. That's, you can think about as 9, and this is your 4. It's choose 4, right? Choose k minus 1. Okay, are we good? So that problem they asked you actually teach you something else about combinatorial proof. So there's another way to prove that, to give out the story that you try to count something twice, and they better be the same. Okay, any questions so far, or any questions so far? We're not done yet. We're not done yet with Sushi and student, but any questions so far about all these 3 answers and the concept of combinatorial proof? Any question? You make me hungry. That's not a question though. It's the same as n choose k. N is the number of sushi. So these two are equivalent, and it's also equivalent to that. Okay. Any other question? Any other question? Okay. If not, let's do something more interesting. Yes, you prove it by writing the proof that, okay, let there be n student, n sushi, and k student. We want to count something, and you count first way, count second way, and you get n choose k. And this thing you get a complicated sum. And then they, well, since we are counting the same thing, then you can say that n choose k is equal to the sum. Okay, you can read a more formal one on the lecture notes, but this is the idea, that you can actually prove things by showing that 2 ways to count exactly the same thing. And you better be correct though. If you don't count it right, then you don't get the right answer. Okay, so let's do the next one. A lot of you ask the following: what if you have 10 sushi, 5 students, and this time some student may get no sushi? Okay, give out all though, by the way. Give out all. Some student, put an S there. I could give 10 to the first student and no one else get the sushi as well. So this thing is a valid one. Someone wrote this before. This is now valid. It wasn't valid before because someone doesn't get the sushi, but for this one, I allow at least I allow some number of students to get no sushi. I could be generous, like I can give you like 2, 2, 2. That's also valid. Wait, where did I assume the gender? I did not. No, what did? Oh no. Oh. Okay, count the number of ways to me. How many ways are there? You have a sushi. Now, next time you go to a buffet restaurant, you know what you want to do. You want to count the number of ways to eat your sushi. They have time limit. So let's say 11, choose 5. Any other answer? Now someone may not get a sushi. What you really are like adding? Wait, someone change his answer. Okay, Keith said 9 choose 4, 9 choose 3. It's not exactly correct though. Keith, and know what? You could be right, but you need to fix your answer a little bit. 9 choose 3, 9 choose 2, 9 choose 1, and 1. Okay, don't worry about giving the wrong answer though, because the most important thing is I want you to learn how to fix your answer to know what is wrong. Because most likely your first answer is going to be wrong. My first answer is going to be wrong. Anyone first answer is going to be wrong, but you better know how to fix it. What's the difference between you two answer? They're the same. Any other answer? Restaurant. Whiskey is 14, choose 5. Okay. Okay, Saran and Alexei seem to have the same idea. Can you tell me what it is? Like, like explain to each other and come up with one solution. Bye, Saran. Heavy rain means no internet. Actually, I was wondering for quite some time, why is it that rain has to do with the internet? At least in Thailand, right? You know, when there's a rain and if you use DSL, not the fiber optics, for some reason, like if the rain affect the fiber optics, that I kind of sort of understand. But the rain and DSL, that one I never really understand. There was someone trying to explain to me that water gets into DSL cable and then mess up the signal. I was like, come on, no, come on, that's not gonna be what happens. But if it's like fiber optics, right, I could understand because the glass, water, and air, it has to do with the index of refraction and so on. However, the fiber optics never have problem, but DSL has so many problems. Okay, so let's do this. Let's do this. So I think Salan and Alexei is trying to do the same thing. Both of them are most. Wait, what? Why are there 6 students now? Why are there 6 students now? Why are there 6 students? So what is 11 to 6, Saran? Why are there 11 to 6? Oh, Alexei, you have the same idea. Why? What is 11 to 6, by the way? Okay. In the meanwhile, since Saran is thinking, Keith, tell me what is 9 choose 4? Keith, no one tell me what's 9 choose 4. Okay. Everyone gets one. And 9 choose 3, that means one person, right? One person doesn't get sushi, right? Okay. Then everyone gets the idea, right? So 2 people doesn't get sushi. This one is 3 people. Gets no sushi. This thing is close though, but not correct. 4 people. Gets no sushi. Okay, I think everyone understand the idea, right? So they want to add up, but I recommend you not to do this. But it's not exactly correct. Exactly. That if you think about it, if you spell out the last term, what it should be, right? The number of way 4 people do not get sushi. There are 5 ways, right? So it's 10, 0, 0, 0, 0, or 0 and 10 and 0, 0, 0, and 0, 0, 10 and 0, 0, and so on. You get the idea. Because you can switch around. Like, so for example, when you say that 2 people don't get the sushi, I ask you which 2. It could be Keith and Nawat, right? Because they give the same answer. 2 people who don't get the sushi, I ask you like which 2. So if you want to it this guy to be more correct, it should be the following. Okay, let me try to fix it for you. And this time it's going to be correct. Okay, plus now you have 5 and then choose 2 people who don't get to choose. Choose the 2 not get the sushi. Right, and each one of them has 9 choose 3. Right, plus and then 5 choose 3 people who don't get the sushi, and 9 choose 2, plus 5. Wait, sorry about it. Oh, sorry, 5 choose 1, 5 choose 2, and 5 choose 3. And then this thing is 9 choose 1 plus 5 choose 4 people who don't get the sushi times 9 choose 0. Okay, so far so good. In the homework, you need to do something close to this. Don't forget this. Don't forget this term. Okay. Now this thing is correct, right? Because you count systematically. Is everyone good? Like this answer is not quite, but it's a good first attempt, right? This is not quite. This thing is fixed. Okay. Is everyone good? Everyone good? Because you forgot to count like which person do not get the sushi. And if you multiply that by the corresponding factor, then you're going to be correct. Okay. Okay, let me try that again. So Keith and Nawaz said, okay, everyone gets at least one sushi, right? So no one get no sushi. For this one, 9 choose 4, everyone is good. But for 9 choose 3, think about this. They said that 9 choose 3, so that means I'm gonna give 10 sushi, right? Sushi to 4 students. This is exactly 9 choose 3. But the question here is which student do not get the sushi? Because for each of the 9 choose 4, right, you have to multiply by the number of ways you can pick the student who don't get the sushi, right? That is 5 choose 1. Cái độc lắc, are we good? Okay. Okay. So you pick who do not get the sushi first, right? So you pick who do not get the sushi first and then give the sushi for the rest. And then there are 5 copies of this because there's 5 choose 1. Okay. But the answer that I like the most is from Risky. Okay. So Risky, that looks like out of the place. What is your strategy? What is your strategy? Can you tell me what is 14? Why are there 15 sushi? It's actually not choose 5. It's actually not choose 5 though, but why did you add 5 to 9? Why did you add 5 to 9? What is your strategy? Why did you bother to add 5 to 9? Just add 5 to 9. Okay, so let me try to explain his strategy in a much better way. This is what you were thinking, except you didn't explain it clearly. I'm pretty sure. No. You were thinking about something really smart. So how about this? Because you remember, right, that if there is this condition, the fact that everyone get at least one makes the problem so nice and everything. How about here is the strategy, right? So I'm gonna give the sushi away to a lot of students. And then I'm gonna take away one sushi from each one of them. So that means the answer 0 is possible. So for example, so instead of giving out 10, I'm gonna give out 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 sushis, right? And now you want to partition it into 4. No, partition it into 5 partitions because you want to give them to 5 students. So how many sticks do you need to make it the 5 partitions? You see, Let's see, you see. But bear with me first. There are now 15 sushi for some reason. Okay, there are now 15 sushi for some reason. I want to partition into 5 partitions. How many chopsticks do I need? Not 14 sticks. You want 5 partition. You want 5 partition. You need 4. You need only 4. 1, 2, 3, 4. And here is that looks better. So let me make this guy. Let me make it look like this. Okay. So now you know the number of sushi to give to 5 students, right? So and then here's what I'm gonna do. I'm gonna give A 3 sushi. I'm gonna give B however many sushi, 5 sushi, right? C you're gonna get 1, and D you're gonna get 3, and E you're gonna get 3. And then what do I do? But now you ask Ajahn, but you have 15 sushi now. And everyone get at least one as well. It's like different problems, right, Ajahn? What do I do to make sure that I only give out 10 sushi? Take away from each student. Right? If from each student, I'm gonna take away 1. So that's good. So that means this answer maps exactly to this answer. A gets 4, B gets 4, C gets 0, D gets 2, and E gets 2. Is everyone good? This is a one-to-one mapping. Okay. So the question of giving away 10 sushi to 5 students, right? 10 sushi to 5 students and get at least 1. Let's say at least 1. This is exactly the same question as giving 15 sushi to 5 students and everyone get at least 1. Then take away 1 from each student. Is someone get to see that the 2 are equivalent, right? Okay. Does everyone follows? That sounds like a good strategy. But what's the reason to do so? The reason to do so is because now you are going to have 10. I think we agree, right? What now these numbers are going to add up to 10. All these numbers are going to add up to 10. And someone may not get any sushi, right? Like that Mr. C over here. You will not get the sushi. And that's the reason why we do it. So the answer is going to be not 15, but 14, choose 4. Let's see how we get. Okay, so it's a 14, choose 4. Which looks the nicest one among these answers? Okay, I'm gonna pick risky. Pick risky is choose only 4. Are we good? So now we can modify. So that's why I teach you with at least one first. So you see the answer. Why 14? Because there are 14 space. No, I did not come up with this. I may have come up with this when I was in like Mohoa. I may have come up with this, except I don't know what it's called. But this thing is a standard technique. Like I said, the name is stick and stone, not sushi and chopsticks. Stick and stone. You can Google this. It's a standard technique. Okay. The reason is 14 because you have 15 sushi, so there are 14 space around them. Way back then, sushi was fancy. Way back then, you know how expensive salmon was. You know, salmon and hed kem tong. What was it called in English? Hed kem tong, where you eat sukiyaki. Used to be extremely expensive. Yeah, enoki used to be extremely expensive. Like, but now you can buy it for like really cheap, like 10 baht a pack for enoki. Back then, it used to be like 100 because people doesn't know how to grow it yet. So when people know how to grow, how to farm, so salmon used to be non-farmable until someone figure out how to farm it. So why does taking away like that works? Because you want to satisfy two conditions, right? You want to make sure that the total number of sushi everyone gets is 10, and someone may not get sushi, right? We want to make sure these two conditions is met. If you don't take away at all, if you don't take away at all, then you have 15 sushi, and everyone get at least one as well. Yeah, so far so good. Any other question or any other question? Any other question? When I was in Matayom, I actually came up with a lot of things, except I don't know that there's a name for it. And I sit in the back, and Ajahn used to scold at me every time that I don't pay attention to class because I was doing something funny. Well, if I were in class and I was doing something like here, I was doing something fun, like I was thinking something beyond what they are teaching, and then, or if I am not in class, then I was playing soccer. You know, no one knows. No one is from Son Gulab. No one go to class. Everyone is playing soccer. Okay, so that's one condition. Let me get this one, and then we're gonna take a break. Okay, that's one condition we haven't done yet, right? So that's 10 sushi. 5 students. Now let's see if you learned something today. 5 students, and some may not get sushi, and I may or may not give them all, or may not give all the sushi. How many ways? Okay, so this is like the combination of what you learned so far. This is also the problem of something called the I'm not sure what's the problem called, but it's in your homework. I think it's called subset sum or something. You gotta do it in your homework, like homework 7 or something. Okay. We are like way ahead the homework right now. But you know, you have the record to come back and watch it. Okay. Okay. I'm gonna make you some restriction. Answer me this. It's some number, choose some number. Find the right one. Don't give me the sum because we explained the sum many times already, right? That they are going to be equivalent to combinatorial proof. Give me these two numbers. Figure out how to place the chopstick and then you're good. You can be really creative on this one, but you can be really creative or you can be not very creative on this. Doesn't matter. So Justin is brave. Thank you very much. I can tell you those are really close. Those are really close. The one. You guys want to move to another one? So if you get the same answer, let's see how democracy works. Let's see how democracy works. If you want to join one of these answers, tell me. Join. Your ballot is now invalid. Okay, so let's start with Justin because he gave me the answer first. Okay, let me draw the 15 sushi for Justin. 2 seconds, Justin. Wait for your sushi to be made. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. Okay, why 14? And why 5? Tell me why 5? Why 5? Why 5? What's the 5 down there? What's the 5 down there? That number. Or someone can tell me as well. What is 5? What if you have 5? You're probably doing the same thing. Right. 5 is plus the ajahn, right? 5 means because I'm not giving all the sushi, that means there is another fake student. Okay. So Justin do the following. So the last one is ajahn, right? Okay. Now you see what went wrong, right? Now, because Justin said, okay, ajahn, there are 14 slots, right? And the ajahn get whatever to the right of the last one. Okay. So we have the same problem, right? Ajahn will get at least one, but we know that I may or may not get any sushi. So just make another spot for him. So there are actually 15 spots. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. There are now 15 spots because Ajahn should be able to land here as well. Okay. So the answer should be 15. Choose 5. And that's how you would count things like this. You can see that if you have something that is so complicated to count systematically, maybe you make something that is equivalent. right? And then you count that one. It makes your life a lot easier. So this is the heart of the second stone. Okay, so the strategy is the same. Actually 15, not 16. Well, but you need to take away one from Ajahn, right? Then Ajahn may not give it up. Actually 14, not 15, sorry. It's 14. Okay, let me wrap this up. Let me wrap this up a little bit. Sorry, I was a bit confusing. Okay, so it's the same idea as before, right? You add the Ajahn. Okay, you add the Ajahn, right? But remember, after you add the Ajahn, no, Saran, you are wrong. Justin is right. Saran, you're wrong. Because remember, Justin didn't know that he was right. Okay, so everyone is clear, right? That we have the problem with the last spot, whether or not to include the last one. Think about this. Okay, so there. Okay. Let me take a deep breath, and now I'll start. I'll start again. Okay, so the way we do this is we're gonna have 15 sushi, right? And we're gonna give it away to 6 students. Yeah, we're gonna give it away to 6 students, which the last student, you know, is a fake student, is Ajahn. Okay. He is scamming sushi from the student. Okay. So the last student is the Ajahn. But remember, after you give away 15 sushi, right? What you need to do is you need to take away one from each one of them, including the Ajahn. So the Ajahn already include the case that he doesn't get the sushi already. Right? So Ajahn doesn't need that spot. That spot is not needed. So you only pick to how to place 5 chopsticks from the 14 places, not 15. Okay. So I'm fixing Saran. Saran, Justin, are we clear on who is right? Because you will need to take away one. Yes, if it's 15 at a time, we get. Where does 15 sushi come from? Remember, because actually it should be 16, right? Otherwise we don't add up to 15. Yes, should be 16. Thank you. Okay, so let's fix it. Let's fix it again. You are confused? So good. Should I be 15 or 16? I'm confused too from the chat. No. You should have 16. Sorry about it because you're taking away 6 sushi. Right? There are 6 sushi that you were taking. So that means the initial one you should have. Yes, the initial one you should have 16. Sorry about it. So Saran is correct. Okay, sorry about it. Because you have. Okay. Sorry. Sorry. It should be 15. Okay, here's how. Here's how. Sorry about that. Because remember, okay. Let me start again. Sorry about that. Let me start again. Remember at the end, right? We're gonna give sushi to 6 students, right? And one of them I know is a fake. And then after we give away 6 students the sushi, we're gonna take away one from each one of them. Okay, we're gonna take away one from each one of them. Okay, so we're gonna give some number of sushi and then to 6 students, right? One of them is a fake. So this is 5 plus Ajahn. Okay, and then the next thing that we're gonna do is gonna be take away one from each. Okay, so that means we take away 6, but we want the total. We want the total to be 10. So that means you need at the beginning, 16 sushi, right? So you need at the beginning 16 sushi. Okay. So did I have all the sushi I need? Wait, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I need another sushi. Okay, good. Right? And because 16 students, 16 sushi and 6 students, you know how to distribute the sushi to all of them. That's going to be 15. Choose 5. Right? Is someone good with this answer? Right? We take away 1 from each. Because think about this. Okay, Anatat, this is a good question. So for example, if you have 16, right, I can give to six students. I can give 2, 2, 3, 2, 3, 1, 5, 10, 12, and 4. Okay, and remember this is a done. And I said that this is if you have 16 sushi to give away, but I only want to give away 10. So I'm gonna take away 1 from each one of them. So this thing gonna map exactly to the answer, right? This is what we count, and this is what we want. Okay, so we want 1, 1, take away 1, 2, 1, 2, and 3. And that's how are we good? Right? Because when you give 16%, you have too many sushi. You take away 1 so that you map it back to here. Right? As long as this guy is 1 to 1. So that means the number of answer here and the number of answer here are going to be the same. Right? And we make sure that this guy, because we take away 1 from each one of them, that they add up to 10. How do we know that's from 1 to 1? Good. One way that we can know that it's 1 to 1 is if you can go back and forth, right? Right? So to go from 16 sushi to 10 sushi, that's easy. You just take away 1 from each one of them. To go from 10 to 16, you know that you give away 1 sushi to each student. Right? So there's 1 to 1 corresponding because you can map back and forth. That's actually one of the part that I asked you to read the lecture note and do the homework. And how do we get? It's 1 to 1 because there's an inverse. Right? We set up 16 sushi, we give it to the 6 student, and we take away 1 from each one of them and kick Ajahn away, then you're going to get the answer. Right? You have 16 sushi, you give it to all the students, you kick the Ajahn away, and then you take away 1 sushi from everyone, then you get the answer. There are many ways to reason about this. The other way to reason about this is to place the chopstick on the sushi. Let me show you before we Should we take a break or should we call it a day? I think if I do this, then I'm not gonna start a new topic today because we need to do the returns and such again. 1, 2, 3. Okay, let's do this. There's no way to place the chopstick right on the sushi. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me make 15 sushi. So let me show you another one or two. Some people do this. Ajahn cannot do this though. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. So this thing is 15 sushi, by the way. Now, here's what we're gonna do. I am going to place the chopstick right on the sushi. Okay, so here's one way to do it. So let me do this. Some chopsticks gonna be next to each other, right? And 1, 3, 4, and 5. Okay, so you can reason about like this as well, right? If you have 15 sushi, and now you're gonna make how many partition? 1, 2, 3, 4, 5, 6 partition, right? You're gonna place 6 partition because you want to give away to 6 students, like 5 plus Ajahn, right? Think about what you get when you place the chopstick on the sushi, right? Then you know that the first guy gonna get 2, the second guy gonna get 0, right? The third guy gonna get 2, 2, and what? 4, and then 0, right? Think about this. How many sushi are there in total that you give away? It's gonna be exactly 10. Right? Because you start with 15 and you place a chopstick right on the sushi, 5 of them. So there are, you always take away 5. Right, the sushi that is on the chopstick, those do not get used. Okay, so then that means the number of ways is exactly 15 choose 5 because you choose 5 things for 15. You choose 5 sushi as the chopsticks. Yes, you can transform sushi into chopsticks. Are we good? Because this way you guarantee that some of them could be next to each other if you want. Because if you place a chopstick in between the sushi, you don't get what you need. Are we good? This is another way to reason about it. There are many ways to reason about this. Okay. Some people prefer placing the chopstick on the sushi. Doesn't matter. Pick one. You can turn one into another with clever tricks like taking away and whatnot, right? So for example, Thanatat doesn't like the idea of taking away. You can think about it as placing the chopstick on the sushi as well. But in effect, right, you are essentially taking away that sushi. Right, you're taking away that sushi. Are we good? You can call it that. Any questions so far? Or any questions so far? Okay. Don't it tastes good though. There is a difference between wooden chopstick and aluminum chopstick. Some of the feeling that you get from the sushi is actually from the chopstick itself. Okay, so any question though? Any question regarding the combinatoric proof and stick and stone? I think I'm gonna end the class today though. I'm gonna end the class today because I forgot to take a break and then you have midterms to do. We're gonna start on probability next time, which we're gonna come back. Probability is about how to scam people because people don't understand probabilities. So we're gonna teach you how to scam people. Usually I play trick here, except this trick requires 2 people and except you're online, so I cannot play that trick to you. We scam. Quantum mechanic is not a scam, but But when you see quantum in front of any product, it's most likely a scam. Okay, so if any question though regarding the midterm and so on, if not, we're gonna call it a day. Any question regarding the homework, the midterm? So the midterm, you can use your iPad to fill in. You can type your LaTeX if you want, as long as I can find your answer, it's fine. If you do not have any of those, you can print it out, write it down, and scan it back. And by scanning, it's not taking a picture though. At least use an app called Cam Scanner or Doc Scanner or whatever scanner there is. Okay, so at least it's aligned. So the reason that I want you to put it in the same format, think about how many I need to grade. There are 2 sections, right? No pictures. If you take the picture, at least put it in Cam Scanner so it makes the alignment and everything. The midterm cover homework 1 to 5. So that should be lecture 1. What lecture? Probably lecture 1 to 11 or 10, maybe 12. But homework 1 to 5, I'm not sure which lecture. Maybe there's something across. When's the exam again? Right now. Exam is posted on Canvas. It's since 8 a.m. today. But you have until Sunday to submit it. You can look at it on Canvas. Okay. How? Okay. So let's call it a day today and see you on Thursday. We're gonna start on probability. How to scam people. Little O and big O. Look at the limit. Just figure out the limit. Little O and big O is it's like less than and less than or equal. You just check the limit. Just check the limit, right, of F over G. I don't remember the definition, but the definition is on the exam. Yeah. Yes. Yes, you can do that. Okay, bye everyone.